Welcome students to another video lecture with Mr. Kinnett here. We are going to be learning about 10.3 in our textbook, which focuses on the mean absolute deviation. And I'm going to have you pause here and copy down what you see. Okay, welcome back. So it looks like a big scary word. You're going to realize that to do this concept of mean absolute deviation, which they will call MAD sometimes, it's really repetitive and it is really long. So it's going to be the same thing over and over and over and over again, being repeated. The key is to stay organized. So that's why that step 2 is start already. Whenever I really need to be organized, we need to make sure that we draw and keep it on a table. So when we find the mean absolute deviation, this is a precursor skill to two really important things you're going to use in the future. In science and math, you're going to start learning about things called standard deviations, and this is really close to the same thing as a standard deviation problem. And also in math and science, you're going to use this skill later on whenever you're finding linear regression lines. So please realize we're learning how to do this skill right now when it's nice and isolated from the concept, but it does make it a little harder when you try to figure it out when you're doing all the stuff together. So we isolate it, and we're just learning right now how to find a mean absolute deviation. And this will lead into your future on standard deviation and linear regression lines. So I'm going to get us 2 slides ahead here because you were able to copy down the first 3 steps, but not all 5. So go ahead and copy down the last 2 steps. Pause here and copy down what you see. Okay, welcome back. So hopefully when you read these steps, you realize nothing here is too overwhelming. You know how to find the mean. We just focused that in our last lesson. I believe you understand how to create tables. We're going to find that this step 3 is the longest step, but it's not actually that difficult. It's just repetitive. Then we're going to find out why they call it the mean absolute deviation. It's because we're going to do another mean of just the deviations in the end. And it turns out that thing you end up with is the MAD, or mean absolute deviation. Again, all these steps don't really make sense until we apply them to the problem. As I show you this problem, it's going to be really important that you realize that when you copy it down, you have to copy this down exactly. So if you're looking at the boys' number line right now with the dots, the dot above 60 stands for 60. The dot above the next dash stands for 61. There are 2 dots above 62. You need to be really exact when you copy this down, or you're going to come up with some funny looking numbers, or it won't apply to our problem correctly because you sloppily copied it down. So please take your time and copy this down precisely. And before I move on, I also need to add one more direction. We're going to round to the 10th place when necessary. So let's add that direction in, and we are going to start finding our mean absolute deviation. So go ahead and copy down what you see here exactly. Please remember that these dot graphs need to be done accurately. So pause here and copy down what you see. Okay, welcome back. Step 1. What does step 1 say to do whenever we're finding the mean absolute deviation? Yeah, you're right. It means to find the mean. So we're going to do the girls' problem together through this video lecture, and then we're going to do the boys' part of the problem together in class to make sure you understand how to do this. So first off, whenever we find the mean, we should have our numbers listed from least to greatest, just to make sure we're interpreting the dot graph correctly. How many of you were able to find these numbers on your dot graph? Nice. I think I'm missing a number. I forgot to add a third 64. There's not 2 64s, there's 3. Thank goodness I caught that error ahead of time. Okay, now we need to find the mean. What I would like you all to do is pause here and find the mean for the girls on your own before seeing what the actual answer looks like. So pause and derive this on your own. Okay, so now you get to see how to work it through. It's 59 plus 61 plus 62 plus 63 plus 64 plus 64 plus 64 plus 67. Hopefully this time, not like my other lessons, I have actually used the correct numbers. Divide it all by 8. Once we actually add those up and divide by 8, you can use a Google calculator for this lesson. So if you had not already, please have one ready to go. And this mean for the girls is 63. So we have found the mean for the girls. Step 1's done. Step 2 says build a table. When we build our tables for these problems, we're going to want to try to create 3 columns for our information. It's the middle column that needs to be the largest because we're going to show math inside of that column. So I'm going to make a really simple chart. And the middle column is going to be the biggest of my 3. And in the first column, you're going to place the data. And our data was 59, 61, 62, 63, 64, 64, 64, and 67. Not too hard. In the middle is where all the action's going to happen. And I would love it if you wrote what I'm about to write in this column box here, but I may have to use a little bit of the above of the column box because I may run out of space. So what we're about to do in this middle area is we're going to take the absolute value of the data minus the mean. And that's where we get this absolute value phrase in mean absolute deviation. Is we're taking an absolute value in here. So showing the first problem, you would use 59 minus, what was our mean again? Yeah, 63, and take its absolute value. So 59 take away 63 is -4, and -4's absolute value is 4. And what you've actually just discovered there is the deviation. So our last column is going to be called the deviation. And what deviation means is it's how far you are from something. And in this case, what we're calculating is how far every piece of data is from the mean of the data set. And that's, again, why we're going to call it the mean absolute deviation. So now we just do that same exact problem again, but with 61. 61 take away 63 is -2, and the absolute value of -2 is 2. Then we perform it with 62. We're going to keep on doing this. Notice, none of this math is really hard, but I can definitely see how it's long. That deviation is 1. And then we're going to do it with 63. 63 take away 63 is 0. Absolute value is 0. Not hard. And then we're going to do it with 64. That gets us a 1, which turns it into a 1. Remember, at the end, that was not a 631 that I wrote right here. That's 63 in the absolute value symbol. Turns out that math is identical when the data points don't change. So we still get a 1. And our last one is 67. Take away 63's absolute value. It is 4. Okay, so now we have the deviation of every data point from the mean. That we're on the final step. What does that last step say, or sorry, fourth step say to do? We need to find the mean of the deviation. So now we just have to do one more mean problem. And what we are actually solving for here is the mean absolute deviation. And what we do to find that is you add up all the deviations. Remember, 0 is a number. Don't be a numberist. It matters. So pause here. Go ahead and add that up. And again, if necessary, we're going to round to the 10th place. Hopefully you've used your Google calculator, and you have likely ended up with 1.75, but the directions are going to ask us to round. So we're actually going to say the MAD is 1.8. So we have just found that the mean absolute deviation is 1.8. And what this number stands for is how far on average every data point in our data set is from the mean. So you can start to imagine here. If your MAD is really large, that means that most of the data points don't fall close to the mean, which means your data is really spread out and usually will mean your data is not good. If your MAD is a really small number, it means that there's not much deviation from the mean, which means all your data is really tight together and likely means you have a really accurate and precise data set. So again, we just did the girls' problem together. We're going to finish up the boys' problem together in class. So if you have any questions, like always, please write them in the question column. Please add notes to yourself if you have questions along the way. Let me know. Ask in class. I hope to see you soon, students.